Welcome, Honors Algebra 2 students, to Chapter 7, Day 3. We're going to talk about factoring. I have two formulas up here on the right, which we're going to use a lot in this chapter, so let's make sure we have those written down. The first one is the sum of perfect cubes. So here, for example, we would have an x cubed plus a y cubed. This is the formula that it would factor to. X plus y, in parentheses, times x squared minus xy plus y squared. That is if you have a sum of perfect cubes, you'll use this formula. If you have a difference of perfect cubes, so x cubed minus y cubed, you would follow this formula. Notice if this sign is negative, then this one's negative. This one's always the opposite of that sign. And then the last are always going to be positive. So try to figure out a way to remember this if you don't follow just by looking by the signs, but after a lot of practice, we'll be good to go. But I like to think of same sign, opposite sign, always positive. Same, opposite, always positive. You might even want to look at the acronym SOAP if you want. Same sign, opposite sign, always positive. Up to you. Just a fun little thing. Okay, let's start some basic factoring, then we'll get into these perfect cubes a little bit later. Looking at example 1, 4x squared minus 12x plus 9. We need to factor. Because this term up front is not a 1, you cannot just do a nice add multiply. Okay, you'll have to split the middle. So for example, you could look at this and maybe you see it already. That happens. So maybe you see it, you're like, okay, this is going to be 2x minus 3. I'm going to multiply by another 2x minus 3. Check it by foiling, and you'll know that it's correct. Please simplify it, though, because it's the same term. It's really just 2x minus 3 squared. Now, if you don't see it, there is what's called the split the middle method. So split the middle. And I'm going to walk you through with this next example what split the middle method is. Again, because the a value is not 1, we're going to take 12 times 12, so our a and our c, multiply them together. You get 144. Now you're looking for terms that add to 25m and multiply to 144m. 25x and multiply to 144x. Okay, long day. So looking at this, we're going to split that middle term. You're going to leave the 12x squared. You're going to leave the plus 12 at the end, but you are splitting this middle term up. So instead of writing 25x, I'm thinking of terms that add to 25, multiply to 144, and that's going to be 16 plus 9. 16x plus 9x equals 25, and it multiplies to 144. You have two terms, so you're going to group, which means factor with the first two terms, and look for a greatest common factor. You can take out a 4x, leaving you with 3x plus 4 remainder. GCF with the next two terms. You'll take out a plus 3, and you're left with 3x plus 4. Notice these inner terms match. They must match. So if you're doing factoring and they don't, you need to go back and find a mistake. Because they're the same term in both, I can just factor it out with leaving left over 4x from the first term and a positive 3 from the last. And that would be your factoring of that trinomial. Yes, if you were to be able to see that from the beginning, you don't have to show all those steps, but in case you don't, we have the split the middle method. Okay, example 3 is our first sum of perfect cubes. Notice it's sum because of addition, and it's a cube because x is cubed and 8 is a perfect cube. So maybe I'll rewrite it as x cubed plus 2 cubed. so I can really see what is my x, what is my y, and I'm just going to plug it into this formula. So the first one is take x plus y, and my y in this case is 2. That is the term that's being cubed. We're going to multiply it by the first term squared minus the first times the second term. So minus 2x plus the second term squared would be 2 squared. You would get 4. And that's your final answer. Let's look at the signs one more time. Because it's addition, we'll have the same sign, opposite sign, always positive, if you're ever confused on the signs. Looking at example 4, I see 3x to the 4th minus 81x. No cubes, not even 3 terms. So the first thing I try is, hey, can I find a GCF? Okay, when in doubt, look for a GCF first in every problem. That's always a great idea, to look for a greatest common factor to make your problem easier. Here I can factor out a 3x from both, leaving me with an x cubed minus 27. Here now is a difference of perfect cubes. X cubed minus, this would be 3 cubed. I'm going to rewrite it. Don't forget the 3x on the outside. I'm going to rewrite it as those perfect cubes so we know exactly what my x value and my y value is. Using our formula right here, difference of perfect cubes, the 3x stays. My first term is x minus 3. My second term is going to be x squared plus x times y, or 3x, plus y squared, which would be 3 squared, 9. And that would be your final answer. Because it's subtraction, same sign, opposite sign, always positive. Looking at our next example, 64x cubed minus 125y cubed. I'm going to see if it could possibly be difference of perfect cubes. My variables are perfect cubes. Let's see if our coefficients can also. So I'm going to zoom in here. Let's see if I can make this possible. Well, 64 is really 4 to the 3rd. 125 is really 5 to the 3rd. So I was able to rewrite those as perfect cubes, which means 4x cubed minus 5y cubed. This whole thing is my x, or my first perfect square, perfect cube. And then here is all my y, my second perfect cube. So whenever I'm inputting x and y, this is my x term, this is my y term, because they are the perfect cubes. Since I'm doing difference of perfect cubes, let's keep our formula. We take our first term, subtract it by our second term. We're going to take our first term squared. So 4x squared. This whole thing is being squared, leaving you with 16x squared plus our x times y. So 4x times 5y will give you 20xy. And always positive is our last term, which is the y value squared. 5y squared will be 25y squared. And you can leave your answer just like that. You use the difference of perfect cubes. And now we have one left. This one is a sum. The first term is d to the 6th and then h cubed. So maybe I'll try to get sum of perfect cubes because I have the sum and I already have a cube. So maybe if I rewrote d raised to the 6th power as d squared cubed. Do we see now that we have that sum of perfect cubes? This is my first value, this is my second, and now we can plug into our formula. Because it's addition, we start with addition as well. Your first term plus the second. First term squared means d squared squared. Exponent rules, you multiply. We're going to subtract the first times second term, so d squared h, and then we square our second term, h squared. And that's your answer using our formula of sum of perfect cubes. As long as you find the perfect cubes, the first value is your x, the second is your y, and then you plug into the formula. Now, we could have an example here, x to the 6th minus y to the 6th. That can be solved two ways. Whatever way you see first, run with it. As long as you simplify fully, there will be no problem. So here, the following example can be factored as either a difference of two squares first, that's going to be my first one, or a difference of two cubes first. Right? Both ways work. So how about we do difference of two cubes? We'll look for that first. Then we'll look at the difference of two squares the next time we solve it. Okay. So difference of two cubes. Let's find my cubes. That means instead of x to the 6th, I'm going to write it as x squared cubed minus y squared cubed. Now it's clear to see this is cubed minus this cubed. So a difference of perfect cubes. Okay, now that I see this, let's plug into my formula. So the normal formula is take your first term, subtract your second term, multiply it by your first term squared plus your first and second term plus your last term squared, so y to the 4th. Now, above we were able to leave our answer because we couldn't simplify anymore. But do you notice right here, this is now a difference of perfect squares. So I need to simplify fully from this step. If I look here, simplifying or factoring you can think of, you get x plus y, x minus y. And of course, your term that's left over. So please make sure you simplify all the way, factor all the way possible, especially here when you have the difference of perfect squares, you have to keep going. That could be one potential answer you get if you factor this with difference of cubes first. What if we saw difference of two squares first? So same equation, but if you look at it a little different. So I write the first term as x cubed squared minus y cubed squared. Now it's a difference of perfect squares. If I looked at it that way, that's my factoring that I did right here. I'm going to zoom in for us. So the first thing I would do to factor, first term plus the second term, first term minus the second term. And this is what we practice at the beginning of these notes, right? Just a normal factor into these two terms. Now here, notice, I have the sum of perfect cubes, and I also have the difference of perfect cubes. So I need to simplify both of these. I cannot leave it like this. So simplifying this one, it's the sum. So we're going to start with x plus y times the first term squared plus the first minus. First, second, always positive y squared. So that is your sum of perfect cubes, the formula we just wrote at the beginning. Difference of perfect cubes will now be x minus y, x squared plus xy plus y squared. That would be your final answer. You can't simplify anymore. You can't go down any more factors. So this could be the answer that you give. Look at them. They look different. Both are correct. So depending on what you see first will depend on your answer. Both are correct. Yes, one of them has 3 terms. Yes, the other has 4, but they're still correct. Almost done, my friends. We're now going to look at a nice quadratic equation. So if you have a basic ax squared plus bx plus c, where a, b, and c are integers, they can be factored into factors with integer coefficients only if b squared minus 4ac is a perfect square. Hopefully you're thinking, okay, b squared minus 4ac, that sounds familiar. Yes, it should, because it is the discriminant in the quadratic formula. It's what comes underneath the square root. So what we're saying is, if that is a perfect square, then voila, you'll have integer coefficients for your factors. Let's try it. Looking at the first example, imaginary a value is just 1, right? There's no number there. You can always put a 1. So a is 1, b is negative 21, c is 68, and we're just going to plug into the formula. B squared minus 4ac. So negative 21 squared, 4 times, oh, didn't even write it, it's right, is 1. C is 68. Negative 21 squared will give you 441, positive 441. Minus, this will be 272, leaving you with your discriminant being 169. Is 169 a perfect square? Yes, it is. Perfect square. It is, because the square root of 169 is 13. So that means we're going to have integer coefficients and that it is possible to factor. So based on this value being perfect, your discriminant being perfect square, you can factor. Proving that, if we look at this formula, we can just think of what adds to negative 21, multiplies to 68. Look at x minus 17, x minus 4. So the reason why we do this is because you might think something's factorable and you're trying over and over and over to get this answer and it's not working. Well, a way to check is quickly look at the discriminant. If it's not perfect, you want to be able to find an answer anyways. So don't waste time. Look at the discriminant first, and if it is perfect, then you can keep going. If it's not, we'll just stop. Last example, let's see what we got. A is our 18, B is negative 13, C is 3. Plugging into the quadratic formula, just the discriminant portion, that's all we have to deal with. You'd get negative 13 squared, 4 times 18 times 3. So you'll get 169. Oh, look, we just found that. Minus 216. So you'll actually get a negative 47. Not a perfect square. So looking at this, not a perfect square. So that means you cannot factor. Or you can say what's called prime. So don't waste time. You could have been looking at this for so long. You could have tried to split the middle and it just wasn't working. Because there's not a perfect square, you're not going to have integer coefficients, so you cannot factor that. Okay, I'm sorry. I'm going to write cannot factor with integer coefficients. I'm going to be clear. Okay, so I'm actually going to take the word prime away because it is factorable. Eventually, you can do quadratic formula and all that, but you won't have integer coefficients and they won't be real solutions. Okay, hopefully you feel good about this video. It's a lot of formulas, a lot of simplifying. So take a good look at this and we'll answer questions in class.